Building an interactive application requires designing both a data model and a user interface. These two designs are often done separately by different people, but strong similarities between the data model and the user interface mean that a considerable amount of work is done twice. Our approach is to automatically generate user interface components directly from the data model. First, we show D2M2, the data modeler we've been using. D2M2 Edit is the Delft University of Technology's Direct Manipulation Manager editor. Here is an object called book, which we have already defined. We now add an attribute to the book object. This attribute will be the person who donated the book. We label it donor and give it type text and a maximum number of characters. Now we can select the attributes of this object we want the user to be able to manipulate, and drag them to the interface constructor. User interface objects are automatically chosen and laid out according to style guidelines in the database. This interface constructor is an extension of Sun's Open Windows Developer's Guide. Here's an object called library. This object has associated actions as well as attributes. Notice that this user interface contains buttons corresponding to the actions in the data model. We can also save selections from the data model as files, which can be directly loaded into our automated tool. Iterative design is also possible. When more selections are dropped in a window, new corresponding interface objects are inserted. In addition to pop-up windows, the type we have been discussing so far, the OpenLook style guide specifies the use of base windows. A base window is typically the main window of an application, and usually features a set of pull-down menus. When a data model selection is dropped into a base window, our tool determines which of the standard OpenLook menus each action belongs in, and assigns unusual actions to an application-specific menu. Instead of blindly creating all possible menus, our tool first attempts to fill the preferred width with simple command buttons. A menu is only created when it is necessary to narrow the menu bar. For example, when we set the preferred width to 1200 pixels, no menus are created because separate buttons for all selected actions will fit. If we want narrower base windows, we might request a width of 800 pixels. The File menu is created to shrink the menu bar to the requested width. A still narrower base window will be created if we prefer. Requesting a 400 pixel width causes creation of both the File and Edit menus. The same actions are available in both windows, but in a wider window they can be more accessible. Menu generation is also fully iterative. If we select and add more actions to this window, they will be added to the menu structure in the same way all previous actions were added. If there is room, each new action is given its own button. Otherwise, another menu must be created to keep the width as small as requested. If the appropriate menu already exists, an object is inserted in that menu. In the future, we plan to use more of the information in the data model. This additional information will allow our system to organize related controls and menu items by reordering and inserting whitespace. We also plan to use the hierarchy of the data structure to generate hierarchical menus and windows. Our research suggests that much time and effort in user interface design can be saved if information in a program's data model is used to build a first approximation of the desired interface. Rapid prototyping and consistent design of user interfaces become more feasible using this approach.